All right, so this is a review for test 3 on Friday. So I'm just going to tag some of these, and I'm just going to start the problem for you guys, and I'll work on the problems that you guys want me to finish up. So this problem here, we don't like square roots on the bottom. So normally we would just multiply by a square root, but since it is a binomial, we multiply by the conjugate. So if you remember, it's 8 plus becomes a minus square root of 2. Oh, that looks terrible. Let me rewrite that. So plus becomes minus, so 8 minus square root of 2, and then 8 minus square root of 2. The top will be a little bit of a mess. That's fine, but the bottom cleans up nicely to be 8. Sorry, not 8, 64. 8 times 8 is 64 minus 2, because the square root of 2 times square root of 2 is just 2. So that comes out and it's going to be negative. Okay? So the bottom is nice and clean. The top is the part that's messy. Question number 2, pretty similar to that. Just multiply by the conjugate. Okay. 3. If I rewrite this problem as 125 to the 4th power and cube root of that, you can look at it this way, or you can look at it as the 4th root of, no, the 3rd root of 125 to the 4th power. This one will probably be faster to look at. Because right? So when you're doing a radical or an exponent, it doesn't matter which order you deal with them. Let's see. Number 4, they want you to just rewrite it. Number 5 looks very tricky. And a couple ways of doing it. One is I could just get rid of the parentheses. And the way we do that is we multiply the exponents. Why is that? Remember, there's 2 rules. If I say x squared times x cubed, we add the exponents. This is product of powers. If I take power of powers, x squared to the 3rd power, no matter what that exponent is, we multiply. So it's x to the 2 times 3, which is x to the 6. So that rule follows with what problem number 5 is asking for. We would have to multiply 1/2 to the problem. X to the 1/2, 1 over 6 times 1 over 2, y to the 2 over 3 times 1 over 2, over x to the 1 over 24, and y to the 1 over 6. Okay, let's simplify that to the top. 1 over 6 times 1 over 2 is 1 over 12. Y is 2. Hey, the 2's divide out. Let's simplify that out. So it would be 1 over 3. Let's take a look at what's on the denominator still is divided by x to the 1 over 24 and y to the 1 over 6. Now, if you remember when we were flipping these around, if you're dividing, you're subtracting. So I'm going to rewrite this as x to the 1 over 12 minus the exponent 1 over 24 and y to the 1 over 3 minus 1 over 6. And that's one way of thinking about it. If I'm dividing, I'm subtracting exponent, because if I'm multiplying, I'm adding. So to get a common denominator, this is back from algebra. That's 2 over 24 minus 1 over 24. This here, to get a common denominator, is 2 over 6 minus 1 over 6, right? Common denominator, I multiply the first one by 2, blah, blah, and 1/3 by 2. Now we combine them. We're left with x to the 1 over 24 and y to the 1 over 6. Okay. And that's how they want us to type it. They want to type it as, oh, they want us to rewrite it as, so what's on top and bottom? Actually, they're both on top. So it looks like to me. Yeah, they're both on top. Okay. So you just type it this way as your answer for mine example. Okay, let's take a look at question number 7. Again, if you guys have any questions, go ahead and type them in the chat. Or if you guys have any questions on what I'm doing right now, please, you can ask any questions. Number 6, one of the easiest questions. I guess I put them in the wrong order for easy questions. Remember, negative exponents, you don't belong here. So you actually belong on the other side. You don't belong on the other side. So it'll be x, so y to the 5th goes on top, and x squared goes on the bottom, because the negative means you're not from around here. You're not from around here. Okay. Well, question number 7 is like what we did previously with this negative. Now, you can just say negative means everyone's going to get flipped. You can think of it that way. If you want to take your time with it, you can, of course, separate it. 3 to the negative 1, w to negative 5, over w to negative 2, n to negative 3. And since we're going to do a flip here, you don't belong here, Negative exponent means you are on the other side. So w to the fifth, and then w squared and cubed. Okay, that's what the negative exponent does. It flips your fraction. Now we can simplify this. I have two w's here, and I have 5 on the bottom. We end up with n cubed, 3w. I have 3 more on the bottom. Sure, I can go back to number 3. Jamilith, are you okay with number 7? Share that exponent first, and if it's negative, then you can flip, or you can just flip it, and then you can simplify. I feel like after you write the fraction, it's easier to simplify. That's fine. Okay. So that's number 7. Jamilith, if you need me to come back to this, let me know, okay? I'm going to jump back to number 3 real quick. So for number 3, this exponent tells you how many you have and how many you're looking for. Here's a simple example. If I write 4 to the 1/2 power, that's the same thing as me writing the square root of 4, because I'm looking for 2. 1 out of 2. I have 1, 4.
Everyone? Okay. The second period. Hello, hello.
Hello.
See, no desks here?
And then, so a couple ways of doing this is you're looking for sets of 3. So if I look at this problem, 125, do I have a set of 3 here? Well, this is 5 cubed. 5 times 5 times 5. Oops, 5 times 5 times 5. So we do have a set of 3. So this will be 5, comes out of the radical, and we're left with 4. Then you have to multiply 5 times 5 times 5 times 5, okay, together in my example. So usually if you can get rid of the radical, makes it a lot easier. For these problems, you'll probably be able to get rid of the radical. So 5 to the 4th power is 625 for me. Okay, Eden, is that okay? Or do you want me to do specifically your problem? Okay, let me know if you want me to do specifically your problem. Okay, I see another question. Let's jump to 10. Just real quick, as we get to 10, if you look at this negative and look at these negatives here, we can say you're not from around here, you're on the wrong side of it. So the m goes up, m8, the m3 is still on top, and w is still on top. We have j4 on the bottom, and then we're going to bring down another j2, and then w9. We can combine some stuff. We have a bunch of m's on top. We have 11 m's on top. We have 6 j's on the bottom now, and we can still get rid of some of these w's. M to 11 power over j to the 6, and we have 8 w's left. This rule here, power of powers. So here's one way of thinking about it. I have 3 sets. I have 3 sets of 5v15. In case you forget the rule. If you ever forget the rule, come up with this really basic way of looking at it. Well, if I multiply this, don't we have 3 5s? Can you just share that 3? And then don't we have 15, 15, 15? We have 45 V's. Okay, that's how we get there. And then that's how we separate it. Okay, number 10, simplify, enter the results of a single log. Okay, so we're going to try to combine these logs together, and then if we can simplify, we'll simplify. If we can't, we can't. So one thing we said about logs is if I'm subtracting on the outside, I am dividing on the inside. If I'm subtracting on the outside, I'm dividing on the inside. So what that means is if I say log of a minus log b, this can be rewritten as log of a divided by b. Whatever the inside the log, as long as they're the same log, we can combine them as a division on the inside. So for this problem here, my example, we have a log base 8, so we can write this as one big log base 8 as one big family of 12x to the 8 divided by 11x to the 7. We can simplify that. So we have log base 8 of 12 over 11 because those don't divide out. But the x's do divide out, and we only have 1 left on top. Okay, we have 1 extra x on top. Okay, Danya, how do you feel about that? So if I'm subtracting logs on the outside, means I'm dividing on the inside. Let me jump back to number 1 real quick as I simplify this. Number 1 was a little, is a little tricky. It's because whenever we have a radical on the bottom, we have to get rid of it. And the way we get rid of it, since it's a binomial, it's 2 items, not just 1, is we multiply by the conjugate. And in this case, the conjugate is 8 minus square root of 2. And this is a rule that we always have to remember, is that we don't like square roots on the bottom, so we're going to multiply this by the conjugate. Now, when you multiply a binomial by its conjugate, it turns out it's actually really easy. The plus and minuses will actually cancel the middle term, and it just becomes 64 minus, and square root of 2 times square root of 2 is just regular 2. That's what the bottom is. The top is going to be a big mess. And if you want me, I'll multiply it. 6 times 8, 6 times square root of 2, then square root of 11 times 8, and then square root of 11 times 25 times 2. So that, I'm going to write that over here. 6 times 8 is 48, minus 6 square root of 2. 8 is plus 8 square root of 11. And square root of 11 times 2 is square root of 22. And actually, you can see that there's no like terms. None of these are like terms with each other. So this goes all the way on top. Let's rewrite this as one big fraction, as all divided by 62, because 64 minus 2 is 62. Brittany, how do you feel about that? Are you okay with the conjugate part? Okay, so every time you have something like this, you have to multiply by the conjugate. That is just a rule, which makes our lives a little easier because it's not anything tricky. The only funny part is when I multiply on the top, it might look a little funny. Okay, but as you can see, there's no like terms here. Okay, you guys can always rewind and watch this on the YouTube. I'll upload this on the YouTube later. Okay, question number 11. Okay, 11, write the expression blah, 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 as a sum and difference of logs with no exponents, okay? They don't want any exponents. Now, let me give you a quick review about logs in general. If I give you a log, and if I say x to the 5th power, in this case, let's go ahead and write 4 because of the 4th power here. Remember, exponents get brought down. So this is really 4 log of x, and we have no exponent anymore. And that's what they want us to write, no exponents. So we want to bring down all our exponents. Also, if I'm multiplying logs, I'm adding logs. If I say log of x times y, this is log of x plus log of y. So if I'm multiplying on the inside, I'm adding on the outside. And if I am dividing, I'm subtracting. Okay, so we can do this. I'm going to do it in 2 phases. So I'm going to rewrite this as log x to the 4th plus log y to the 7th minus log z to the 16th. Because if I'm subtracting logs, if I'm dividing logs, I'm subtracting them on the outside. Now I'm going to bring down all the exponents. Take a look at these exponents here. These exponents are going to go to the front. 4 log of x. Bring down the exponents. 7 log of y. And 16 log of z. Okay, so we're bringing them all down. And that's it. These can be pretty easy once you get used to reading what to do with these logs. But the problem is you just have to memorize this. Like if you forget about it, if you forget your little tricks, when you take the SATs, they want you to rewrite it or somehow mix it around, you're going to forget it. But it's not a hard task. Aaliyah, are you okay? Cool. Okay, number 12 is very similar to this question, right? We're going to break it down, bring down, separate the logs, the plus and minuses, and then we're going to bring down the exponents. Now 13 is going backwards. So if I see this 5 here, log 6 plus 2 log x, this 5 here is really an exponent. This 2 here is really an exponent. So if I rewrite it as log 6 to the 5th plus log of x squared, then we can combine it. If I see a plus, that means we're multiplying log of 6 to the 5th times x squared. Okay. So we're writing the logs together, bringing them into one big happy hug. Now, you can see that this question took me like 30 seconds, and this is me showing the work. So you guys have to show the work. It would take you longer to try to get this to work in photomath. So remember, for the test, you have to show work to receive credit. If you guys have questions, go ahead and type them in the chat so I can put them on a list of questions to do. If not, I'm just going to work through the questions with the time we have. We still have another 30 minutes before the end of class. So I can still probably cover quite a bit of questions.
I had a question on number 5.
Sure, let's go back.
So on number 5, do we just type it in the calculator and then we just submit it like that, or will
No.
we have to?
Well, there's number 5, like this question here, number 5.
Yeah.
So I would type it like this: x, and then you'll give you exponent 1 over 24, I'm sorry, and then times y 1 over 6.
All right.
There is no calculator part because we don't know what x is.
All right.
Okay. Okay, let me continue. Okay, number 22. I can jump to 22. Okay, now this problem here is, you know what? I'm going to get rid of number 22, okay? Because we haven't actually learned how to do this yet. So I copied the wrong problem, okay? But it's one of the things that we are going to learn. So I'll go get rid of that right now. Sorry about that. But it's actually really easy once you learn how to rewrite it. So I'm sorry about that. I'll fix that right now. Okay, I can go over number 16. Okay, let's look at question number 16 now. Okay, number 16. We're going to rewrite this using our circle of log song, okay? So to rewrite this, we're going to say log base 2, 3x plus 3 is equal to 4. Rewrite the circle of logs. It's 2 to the 4th power is equal to 3x plus 3. Okay. And then from here, isn't 2 to the 4th power just 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. And then really this is just our algebra 1 problem now. So I'm going to minus 3, 16 over 3. Sorry, minus 3. Minus 3. And then we're going to divide that by 3. So it's 13 over 3, which is approximately 4.333. Okay. So what happens is we're going to use our identity, rewrite this as an exponent because 2 to the 4th, I can solve that. And the x is no longer inside the log, which is hard to get to. Okay, Jimmy there? Of course. So if you remember, logs have this pattern. Log base A of, let's say, C is equal to B. We use circle of logs. 2 to the B power is C. This is the same as me writing A to the B power is equal to C. So that's what I did here. I use a circle of logs. 2 to the 4th power equals to the answer 3x plus 3. Why? Because logs solve for exponents. And 4 is the exponent of 2. 4 is the exponent of 2. That's how we end up with 16 on the left side. And then it turns out it's 3x plus 3 on the right side, which is back to algebra 1 to solve. Alex, is that okay? Or do you need me to explain it a different way? Yes, makes sense? Okay. Okay, let's do number 18. Now, which special log can we use to solve for this? This log, let's go ahead and rewrite this as a log problem, okay? Log, what's the exponent? The exponent is 6x. And the base is e. And this answer is 16. So if I rewrite it like this, we said log e is a special log for us, so that's natural log. Okay? So we can switch this to natural log. And from this point on, we can just divide this by 6 to both sides. X is equal to natural log of 16 over 6. Okay. Aaliyah, is that okay? Okay, let's go ahead and do 8 right now. All right, so number 8, for my question, let's go ahead and redo it. I feel for me personally, it's easy for me to first get rid of all the negatives. See how these have negative exponents here? You're negative and then you're negative. Oh, that's too big. But you're negative and you're negative. So I'm gonna move you back to the other side first of the fraction. So when I rewrite this, it's gonna be you belong here and you belong up here. So m to the 8, m cubed w over j to the 4th, j squared, and then w. Okay. Miley, are you okay with these as I rewrite the fraction? Now they're all positive.
I am.
Okay, so then now we can combine them. M8 and 3 become M11. J6 on the bottom, and then we still have the W's. Sorry, that's a 9 there. W on top and W on bottom. So we're going to cancel these out, and I'm still left with 8 W's on the bottom. Sure, wrong letter. Okay, and then now, since there's nothing else for me to divide, we're done. Okay. Try and go over number 7 again. Let me try show 3 real quick. 3, what happened was I rewrote that as the fraction exponent is actually a radical. That's why it's 3 inside the box. And 4 is still the exponent. I know that this is the cube root of 125 is just 5. 5 to 5, 5. And then we can do the exponent afterwards. I feel like it's easier for us to bring down the number first before we blow it up with an exponent. Okay, back to number 7. Okay, so 7 is tricky because of that exponent on the outside. And we have a rule called power of powers. And that's whenever you take the exponent of an exponent. Okay, let me give you this again. Let me give you like an easy one. If I write x cubed, okay, what happens to the exponent? We just multiply it. That's x to the 6. Because if I write it 1, 2, 3 times, that's the same thing as me writing it x2 plus 2 plus 2. And if I'm adding and multiplying. Now the same thing happens even if that's a negative number. We can use this idea of multiplying powers, so multiplying our exponents together. So this would have been, if I distribute that next exponent, 3 negative 1, w negative 5, over w negative 2, and n negative 3. And what happens when we have a negative exponent? We flip the problem. Okay, so Eden, we flip the problem. So we have 3 on the bottom, w on the bottom, we have w on the top, and then n on the top. Now we can simplify. That gives me a 3, and we're left with n cubed over 3w cubed. Okay, write the equation of an exponential form? Sure. Circle of logs, u to the y power is equal to n. U to the y power is equal to n. Circle of logs, because logs solve for exponents, so this y was an exponent. Y was an exponent. This question number 25, we can do this without a calculator. I see log base 3, but 1 over 27 is actually 3 cubed, isn't it? To make this a little easier for me, I'm going to rewrite this as log base 3 of 3 to the negative 3 power. And this cancels out, leaving me just negative 3. The cool thing here, same idea here, log base 5 of 5 1/4. Logs can bring down exponents. You can bring that down, or you can just say that cancels out. And we're left with, let me go the long way, 1/4 log base 5 of 5. Log base 5 of 5, that nicely cancels out to become 1. And we could just have written, just say, hey, that becomes 1. So 1/4. Just bring down the exponent. Logs are great like that. Number 27. See how we're solving for exponents? We're going to use logs there. Log. Oh, no, that's already a circle of logs. Log base 4 of 17 is equal to x. And then to write this in your calculator, you need to do a change of base. Log of 17 over log of 4. And that calculated answer will be a decimal answer for you. Number 28, convert this into a log form. Sure. So circle of logs, log base 6 of 1522 is equal to k. And then they want you to, let's see, they want you to write this in your calculator using a calculator answer. That's log 1522 divided by log of 6. All right. Kind of made the bell. You guys can always go back and watch these, rewind and watch it. Okay, solve for W number 15. I guess I skipped that one. Solve for W in the equation below. Convert it into exponential form? Sure. So in exponential form is 5 to the exponent negative 3 is equal to W. Circle of logs, 5 to the negative 3 power is equal to W. And then we can rewrite this as 1 over 5 cubed, which can be written as 1 over 125, because 5 times 5 times 5 is 125. So write the answer as an integer or reduced fraction. So that's a reduced fraction. So they did not want a decimal for this answer.